So welcome to the session. And today what I'm going to be doing is I'm going to be running through a little bit more of the technical detail that I went through for my session at DigitalOcean Tide earlier on in this week. And at Tide I was talking about collaborating with Terraform. And one of the things I didn't get the opportunity to do, because it was only a short presentation, was really dig into the kind of the detail on how you can set this up. So that's what this video is going to do. So we're going to look at DigitalOcean and Terraform, how they work together, but we're going to look at some of the elements such as collaboration. So how do we manage things like remote state, and how do we manage workspaces which can span across different environments? And hopefully it'll be a quick video. And hopefully it'll be a little bit fun as well. So what I want to do is I want to walk you through very quickly my Terraform configuration. So what I have is a fairly straightforward Terraform configuration, which is just going to set up a few bits and pieces in DigitalOcean. So a droplet, some storage, and some network settings. And for anybody who's not familiar with Terraform, then Terraform is built using these HCL language, so the HashiCorp configuration language. And what you do is you use these blocks called stanza blocks. So we have a provider block, a variable block, and also we have resource blocks. And you use this to build up your configuration for your infrastructure that you want to create in your cloud provider. So if I go back to our simple block, then at the very top level, the one thing that you kind of need all of the time is a provider. And what the provider does is it kind of controls access to the API. So this is where you'll define things like your DigitalOcean API key, and things like that, some various different settings on that. Then Terraform also allows you to define variables, and variables allow you to make your configuration dynamic. So I've got these variables for instance count, and I'm going to create 2 instances, and I've got a variable which is going to define my region, which is going to be NYC3. If I flip over to my resource, you can see I'm using them here. So I've got I'm using the instance count, I'm using this interpolation syntax, which is this $ curly bracket variable, var, which is shorthand for variable, and then instance count is the variable that I want. So at runtime, Terraform is going to take the value that's stored in my variable here, and it's going to substitute it into the resource. So let's have a very quick look at how that's going to work. I'm going to switch the light off because it's getting dark. All right. So with Terraform, there's kind of 3, maybe 4 commands really that are really useful. And when I've got a brand new set of Terraform configuration like I do here, I first need to initialize it. And what the initialization is going to do is it's going to download the plugins. So it's going to download the provider plugin for DigitalOcean, and I think that's all I'm using in this one. You can use more than one provider, so I could use DigitalOcean and say DN Simple for DNS, or you know, you can mix and match, and there's about 70 different providers which are available in Terraform. So brand new configuration, I'm just running Terraform init. So that's been initialized. You can see there Terraform has successfully initialized, and it's downloaded the plugins that I need. So the next step is to run a Terraform plan. So let's just have a look at the docs on that. So Terraform plan will look at my configuration and it'll work out what needs to be done. So it'll look at the current state, of which there is none right now, and the configuration, and the difference between the two is going to be the output of the plan. So if I run Terraform plan, and that's come back pretty quickly, and you can see that it's going to create 6 resources. So I'm going to create 2 DigitalOcean volumes, which I'm going to attach to my droplets. I'm going to create a load balancer, and I'm going to create a firewall, and I'm going to create 2 droplets. So these are all defined in my configuration here. So if we look at the instance, you can see I've got a resource. It's a DigitalOcean volume. I'm going to call it data, and I'm going to create 2 of those. I'm also going to create a DigitalOcean droplet. I'm calling this web, and I'm going to create 2 of those. I'm going to assign it to the region which is defined in my region variable. I'm going to set the image, so Ubuntu 14.04, and then I'm going to give it a name. So Terraform Workspace, we'll come to this in a little bit, but Terraform Workspace is a special variable which allows you to break things down into workspaces which can define the different environments. So by default, we just have the default workspace. And in the name, I want the count, so it has a unique name. And then I'm going to attach the volume ID. So just quickly looking at this is a little bit different. What I'm actually doing here is, if you see this is the splat operator. So ordinarily, if you had a count of 1, I would be able to do something like this, just data.id. But when you've got more than 1, you can do things like access the first one, access the second one, or you can use the splat operator, and that's going to return me a list. So then if I backtrack, I'm using the element function, and the first parameter of the element function is a list. So that's going to be a list of my data volume IDs. And I'm going to select the element that I want by using the count index. And what this is going to allow me to do is it's going to allow me to assign the volume ID from the volume, from the volume ID which is created when we create a resource of DigitalOcean volume. And this will be a little bit clearer in a little while, but the documentation for all of these resources is available at the Terraform website, and in the providers we can go to DigitalOcean, and you can see there's a number of different resources that you've got available to you. But anyway, we'll come back to that. So then if I look at my network, so again, in my network, I'm creating a couple of resources. So I'm going to create a load balancer, and I'm going to attach the load balancer to the 2 droplets that I'm creating. Again, I'm using this interpolation syntax. Again, I'm using this splat operator so that I can get a list back. And I'm going to create a firewall, which is going to open up ports 22, 80, and 443. Again, same thing with the droplet IDs and using that splat operator. And the benefit of doing this, so the benefit of using this interpolation syntax is that Terraform is automatically going to figure out what it needs to do in terms of the order. So by the fact that I'm referencing the droplet IDs in the load balancer resource, Terraform is going to figure out that it has to create the droplets before it can create the load balancer, which makes it really, really easy for you because you don't need to worry about order. It means you can organize your resources in a way that's sensible to you. So I like to structure things in terms of functions. So I've got network, I've got instance, but you can really structure these however you want. You can have as many of these .tf files in the folder as you like. The only thing that you have to remember is that subfolders are reserved for modules. So I can't create subfolders and put my resources in there without first creating a module. And I might be looking at modules in another session, but we're not going to look at that today. So back to that plan. So we've got that Terraform plan there. Now I've got a plan. What I really need to do is I need to then run an apply. So I'm going to run Terraform plan. I'm going to specify out parameter, and I'm going to give it a name. So I'm just going to call it run.plan. That'll do. And the reason that I'm saving a plan is that when I run a Terraform apply now, it's not going to regenerate the plan. So there's going to be no changes in between me running plan and an apply. I'm going to pick up exactly what I pick up and create exactly what I've just output. So to create my infrastructure, I run Terraform apply, and I give it the plan, which I just created, run.plan. So let's run that. So what Terraform's now going to be doing is Terraform is going to go away and it's going to create those resources for me. So if I flip back to my DigitalOcean control panel and go to droplets, you can see that I'm creating the two droplets which I had defined, and one of them's actually come up, well, they both come up already. That's pretty quick. If I look at the volumes, you can see that I've created those volumes there as well. So that's really, really quite quick. I'm just going to go away now. Terraform's going to create me the firewall and the load balancer. Load balancer will take a little bit longer to create than the droplets because it's got to run its health checks, but it'll come back in just a moment. So let's just go back to that provider. So I'm not putting in my my DigitalOcean ID in my Terraform file because I don't want that to leak. I don't want to commit my DigitalOcean API key to GitHub. So what I can do is I've got two options. One is I can specify the token in the provider like this. The other option is I can use an environment variable. And that's how I'm doing it. And on my CI environment, I will configure it with this environment variable. And on my local computer, I'm using a tool called direnv. So I can be sure that I don't commit that token to GitHub accidentally. So those resources have been created now. I've now got 6 new resources. Go back to DigitalOcean. There's my droplets. Go to networking. I can see my load balancer. I can see my firewalls there. And that was quite straightforward. So that at its very basic is how you would use sort of Terraform. So let's just quickly, before we carry on, show you one more command in Terraform, because we want to be able to clear up after ourselves as well. And for that, I can use the Terraform Destroy command. So Terraform Destroy, again, it's going to check what's existing. It's found those resources which are defined in my configuration, and it's telling me that it's going to destroy 6 of them. Am I okay with that? Yes, I am. And again, Terraform is going to go and it's going to start deleting those resources in DigitalOcean. And it'll take just a couple of minutes, but you'll see that they will get deleted. Again, in the same principle that Terraform is going to use to create resources, you don't need to worry about the dependency order. You don't need to worry about the graph because Terraform is managing it. So it's going to destroy your load balancers before it destroys your droplets, because the load balancer depends on the droplets. So you get the idea. So I'm just going to refresh that and we'll see that those droplets have gone. Right, so that's all gone. So let's start introducing some advanced concepts. And we're going to be talking about collaboration. So I've got a GitHub repo. And I'm just going to open that page up. Tide 2018. Make that a bit bigger. So what I'm doing is I'm setting up a Circle CI job to build my infrastructure. I'm not going to be running it from my command line. I want to run everything from CI. Now, one of the things about Terraform is that Terraform has these concepts of state files. So you can see them here, terraform.tfstate and terraform.tfstate.backup. And these contain the details about your infrastructure. So if you remember back to the plan, a plan is what will be created. A plan is calculated as the difference between the configuration, which is your terraform.tf files, and your Terraform state. The Terraform state files, and there's nothing in this one, are JSON files. They're not really designed to be read by humans. They're designed really just for Terraform. But the thing is, they reside on the disk and they need to be accessible by Terraform. So when you're running on something like CI, which is potentially running in a containerized environment, so it's an immutable setup, you need to be thinking about the state and where the state files go. So you've got some options. You could manually store those state files and shuttle them off into DigitalOcean Spaces. You could store them somewhere else, or you can use one of the built-in mechanisms of Terraform, which is the remote state. So let's have a quick look at that remote state. Now, remote state in DigitalOcean is actually used by, the S3 backend. And the reason we use the S3 backend is that the DigitalOcean Spaces API is 100% API compatible with Amazon's S3 APIs. And this allows us to leverage the S3 backend as our remote state for DigitalOcean. So this means that Terraform, instead of writing those terraform.tf state files to my local disk, it's automatically going to read and write them to DigitalOcean Spaces. How do we set that up? We set that up really easily. So what I need to add is my backend. So literally just copying and pasting the stanza that I have here is enough to get me some of the way. But when I'm using DigitalOcean, I need to go a little bit further. So let's have a look at what I'm going to create for my DigitalOcean Spaces. So it's pretty much the basic backend that I would use for S3, but I need to add these additional elements because we don't want it to do region validation and credential validation because we're not actually using AWS. S3, we're using Spaces. So just by specifying these 5 parameters here, I can leverage this. So what I need to define to get this to work is a bucket and an endpoint. And to get those, I need to go and create a Spaces in DigitalOcean. So let's quickly do that. So in the DigitalOcean UI, I can go to Spaces and I can create a space. I'm going to call this Tide 2018. I'm going to put it in New York and I'm going to restrict the file access because I want to keep my Terraform state files secret. I don't want anybody but myself reading those because they can contain secret information which you don't want to leak. because they contain these secret information, this is why you don't want to check them into GitHub as well. Never check your Terraform state into GitHub. So I'm going to create that space. But what we're going to do is we can start actually populating the information into our backend. Right, so our bucket, we've called this Tide 2018. So that's the name of our space. The key is the location where you want to store this in your DigitalOcean spaces. So you can share a single space for all of your Terraform configuration as long as the key is unique. So I'm going to put the key as Tide because that's the name of my app, and I want to store it as terraform.tf state. The region, now you need the region in there because it's just because we're using the S3 backend. It's not specific to DigitalOcean Spaces. I'm not actually using it. So I can put anything in there as long as it's a valid AWS region. And the endpoint is going to be my space endpoint, which hopefully, has now created. So I'm just going to copy that. So my endpoint is https nyc3.digitaloceanspaces.com. I've created my space in the New York 3. And if you note the difference, I'm omitting the initial bucket name. So I'm omitting Tide 2018 from my space there. I just want to enter this in my endpoint as just the NYC3, so the region.DigitalOcean Spaces. And I'm going to save that. So again, what I need to do, if I do a Terraform plan, so Terraform has told me that I've changed my backend configuration. It's told me that I'm now using the S3 backend and that I need to initialize it again. So I'm going to do Terraform init. It's going to initialize the backend and it's going to tell me I haven't got an access key. And that's absolutely correct. So what we need to do is we need to generate our access key for spaces. So we're going to go to generate a new key, and I'm going to call this Terraform. And then what I'm going to do is I'm just going to switch to secure mode so I can copy and paste those details without leaking it to the whole internet. So I'm using direnv. So what I've done is I've set an environment variable, which is the access key ID, AWS access key ID, and AWS secret access key. And these correspond to my spaces ID and my spaces key. And this is all in accordance with the S3 backend. So you can find all of that information in the documentation here. We just scroll down somewhere. There we are. So now let's try that Terraform init again. So do I want to copy the existing state to the back end? Yeah. Yes, please. And this has all worked. So I've now got my Terraform configuration and I'm not using local state anymore. Oops. DIR, Christ, I haven't used Windows in a long time. What I'm actually using is my state file in my spaces. So if I click on my space, you'll see I've now got a folder called Tide, and I've got a folder Terraform TF state. So this was the file that was residing on my disk. It's now running in DigitalOcean Spaces. So I'm all equipped for remote state now, which is awesome. But then we have our next problem. And our next problem is I generally have more than one bit of infrastructure. I normally have multiple environments. So how do I share environments using the same Terraform configuration? Because if I run Terraform apply and Terraform plan multiple times, I'm going to be changing the same environment. And it doesn't matter if I'm working in a different branch from Git or anything like that, because Terraform is referencing the same TF state. So to get around that, what Terraform has is the concept of a workspace. So you've got the ability to create workspaces, and workspaces correspond to your infrastructure environments. So if I create a new one, and I'm going to call it dev, this is my dev environment, I'm on my dev branch, then what Terraform is going to do is going to create me this empty workspace. So if I run my Terraform plan, it's going to tell me that it's going to create these 6 resources. So let's just run that. And I'm going to apply that. And this is going to create me again those droplets. And then what we're going to do is we are going to change workspace. We can make a change to our configuration, and we can then start working in a brand new environment. So this could be our staging environment or our production environment. It means that we can share the Terraform configuration without having to copy any files or anything like that. We can use a git flow method. This will probably just take about 20 seconds to create there. And while that's going ahead and creating, I think I will just quickly show you those environment variables. So these are the environment variables that we need. So we need the AWS access key ID and secret key to be able to use the S3 backend for DigitalOcean Spaces. We're not actually using any resources in AWS. And I need my DigitalOcean token, which gives me API access for Terraform to allow me to create those resources there. And that load balancer will just take a second. Okay, so whilst that's doing that, I'll tell you what, let's start looking at our CI flow. So we want to run our Terraform configuration on CI. And it's actually really, really easy to do. So I've got this set up using Circle CI, but you can kind of use any CI provider if you're using Jenkins or you want to use Travis or CodeShip or anything. It's pretty much the same concept. With Circle has the ability to run your CI in Docker containers. So I've just got a Docker file which installs a couple of tools. So I've got Terraform and stuff in there. They're pretty much just a sort of a utility. And then if I look at how I've set this up, I've got it broken into steps. So my first step, I'm just going to create a directory for outputting my plan. I'm just running Terraform version just for my information, Terraform init, and then I'm going to select my workspace based on my Git branch. I can then run my plan, and I'm going to output my plan file to a file which is named the same as my Git branch. And then in Circle, because I've got this workspace sort of ability, and I'll show you this in workflow ability, I'm just going to save that so then I can use it by another job. Let's have a quick look at Circle CI. So this is my setup. So I've got 3 steps. I've got a plan, Then I've got this hold step, which is a special step in Circle, which allows me to have manual authorization before I actually change my infrastructure. Then I've got my apply step. And that corresponds to these jobs, which I've got defined in my file here. So my plan runs my Terraform plan, outputs it to a file, persists the file to the local storage in Circle. Then I'm using my hold job, which is a special job, so it's not actually defined, but this is a thing that's, as you'll see in a second, it's going to ask me for approval before it runs my apply, which is going to change my infrastructure. So git status, what do we got there? So I don't want to add that plan. So updated dev. And I'm going to push that to GitHub. And what we should see is this failed because I forgot to update the environment variables on my job for my new stuff, which it has. Right, okay, back to secret mode. Let me update those environment variables because I just generated that new key. So let's rerun that from the beginning. And this should work now because we've got the right keys stored. So my plan's running. You can see that Circle's just going to use my Docker file, and then it runs my Terraform plan. So it's using my Terraform plan because I've got my configuration inside of Spaces. It can automatically go ahead and read that information. And it's correctly telling me that there's no changes because I haven't made any changes to this bit of infrastructure. So if I go back to the job, you can see I've now got this hold step. So even if there were changes, I'm not going to apply those changes without manual intervention. And this is just good practice. You potentially going to use this on your production branch. You might just allow it to run through on dev, but just for a simpler setup. So I approve that job. And then Circle's going to now run my apply, but of course my apply is not going to have anything because there's no changes to be made. So that's passed all okay. But what about our staging environment? Because the whole purpose is how do we deal with multiple environments? What we need to do is we need to add a new workspace. So if I go to Terraform, Workspaces, New, and Staging, and I'm going to create a new workspace. So if I do a Terraform plan, it's telling me it's got 6 resources to add. Even though I haven't changed branch, I'm using exactly the same configuration. And that's because I've used a different workspace. If I switch back to dev, Terraform, workspace, dev, oops, select dev, and run a Terraform plan, it's going to tell me there's no changes. In just a second. You didn't see that. There we go. No changes, infrastructure up to date. Okay. So let's create that by following a Git flow methodology. So rather than me pushing this manually, I'm going to go into GitHub. So this is kind of the approach that you're probably going to take if you're working in a team. So you're going to go to your pull requests, and I'm going to create a new pull request, and I want to merge into staging, and it's telling me that I can merge it. It's showing me the changes. So if I was going to do this as a dev, I can check all my stuff. That looks all good. Create my pull request, updated infrastructure. I can't think of anything more imaginative right now. I create my pull request, and I'm going to get all of those checks. I'm going to see that my Circle CI is working there. Whoever's going to be doing the code review and the approval on this is going to come into this pull request. They're going to have a look at the commits and the files changed. They're going to eyeball it. They're going to say, looks good to me, and submit that review, and then we can merge it. So I'm going to confirm that merge. And now what's going to happen is if we go back to Circle CI and into Tide, we can now see that our staging branch is building. So let's have a look at the plan there. So again, because we're selecting our workspace and just using something which corresponds to the branch, I'm going to persist that. We're now on our hold, so I'm going to approve that. I can make the changes to my infrastructure. And now my apply is running. And that's going to just take a second. And you can see there, it's now going ahead and creating my infrastructure. And I've now got my 2 new droplets, which are called staging. So I'm sharing exactly the same Terraform configuration. I'm running everything on CI, so no local files. But I've got the ability to have that sort of multiple environment. So in a production environment, I'm going to start with dev. I'm going to progress that to maybe testing or staging or something. And then I'll eventually progress that out to production. In the same way, because I'm using those names, so if we quickly just go back to that, there we go, Terraform Workspace, which corresponds to the name of my workspace that I'm in. I'm prefixing everything with that, so I can have that clear delineation between my various different pieces of infrastructure in my DigitalOcean account. And eventually that job will complete and we're all done. So that's really it. I just wanted, as I say, to do a bit more of a deeper dive into the technical side of this, which I didn't get the opportunity to do when I was at Tide the other day. If you want to sort of have a look at this code, you can go to github.com/NicholasJackson/Tide2018, and you'll find the basic configuration in there. You'll be able to see the instances that I'm creating. It's simple stuff, but it's just for an example. The backend configuration, how it's needed. And also if you look in the Circle CI folder and at config.yml, you can see my job that I've configured up for Circle. And we're all good. So thank you very, very much for watching. I hope this is useful. And maybe next time we'll start looking at creating some modules or something like that. If you've got any recommendations, please ping me at Sheriff Jackson on Twitter, and I'm more than happy to look at anything. So thanks again, and I will see you all next time.